Before we begin talking about probability, we're going to lay the groundwork by talking about sets in general. The things that we talk about in this particular section with respect to sets will come up again in probability. We're going to talk about some different terminology, and then later we'll see how it relates to probability. And also within this section, we're going to talk about counting, because that will be another thing that comes up in probability. So just to begin with, sets. A set is just any collection of objects. It could be the set of objects in your backpack. It could be the set of students in Math 120, Section 003. It could be the items on your kitchen table. So a set is just simply any collection of objects. The objects within the set are known as elements. So for example, if you're talking about the set of objects in your backpack, you might be looking at elements like books, folder, pen, pencil, etc. Sets do need to be well defined. There can't be any ambiguity. So if I was to say the set of students in Math 120, that could be a little ambiguous. Am I talking about students in all sections of Math 120, just my sections of Math 120? Am I talking about my hybrid sections of Math 120 or just my night section? So it needs to be very well defined. We often name sets by capital letters and give them either as a complete list or a precise description. So I gave you examples of a precise description of sets, such as the objects on your kitchen table or the set of students in Math 120-003. If I wanted to give them as a complete list, I could simply open up a brace and then begin listing. Let's say it was for the set of students in Math 120-003. I could start listing the students' names, and once I had that complete list, I close the brace. Here you can see some examples of sets. Set A, Set B, and Set C are all complete lists, whereas Set D is given as a precise description. The form that Set D is written in is something called set builder notation. It's the most formal notation that you will see sets written in. If you take a discrete class, you would see this come up more prevalently. The way that this is read is x such that x is an odd integer greater than 20. You can see the precise description right here. And so if I was to go to a complete list, then I would open up a brace, and I'm talking about odd integers or odd numbers greater than 20. So the first one being 21, then 23, 25. You'll notice each element is separated by a comma, and then I can use the ellipsis to show that this is going to go on forever, and then close the brace. The fact is we can describe or define any set we want. However, whether that set contains elements or not is another story. For example, what if I was to ask for the set of students in Math 120-003 who are over 15 feet tall? The fact is there are no students who are over 15 feet tall. So while I was able to give a precise description, if I was to go to create a complete list, I open up my brace and I go to list student names, and there are no students that fall that meet that description, and so I close the brace. When a set has no elements, it's known as the empty set. This is one symbol for the empty set, and this is another.